Hello everyone, welcome to Physics Numericals. On this channel, I'll solve important physics numericals every day with clear step-by-step explanations in simple English. If you want to improve your problem-solving skills, this channel is for you. Now let's begin today's problem. The problem is, when an electric current flows through a wire, the amount of heat produced depends on the current, resistance of the wire, and the time for which the current flows. Using the method of dimensions, establish the equation for heat produced. So, you see, this is basically a dimensional analysis problem. So, here we consider heat produced to be H. Given that H depends on resistance R, current I, time T, the three factors. So, we can say H equals to K R to the power X, I to the power Y, T to the power Z, where we don't know X, Y, Z, but we know that K is a dimensionless constant. Now, let us find out the dimensions of left hand side and right hand side, because in a dimensional analysis, we have to equate the dimensions of left hand side with the dimensions of right hand side. So, here we get heat mL square T to the power minus 2, because heat is energy and the dimension is surely B of energy. Now, resistance R equals to mL square T to the power minus 3 I to the power minus 2. Why? If you have forgotten this, then I want to remind you R equals to V by I, voltage by current, and R equals to work by charge, and obviously I will be there. So, by substituting all the dimensions, you get mL square T to the power minus 3 I to the power minus 2. Now, the dimension of current, this is I, and dimension of time, this is capital T. Now, substitute the dimensions of left hand side and right hand side should be equal, all the dimensions. So, left hand side we got mL square T to the power minus 2, and on the right hand side we can write mL square T to the power minus 3 I to the power minus 2 whole to the power X, I to the power Y, T to the power Z. Because we are substituting the dimensions of I, R and T. So, after simplifying we get m to the power X, L to the power 2 into X, T to the power minus 3, and here Z is there, so minus 3x plus Z, and I to the power Y, here minus 2x, so minus 2x plus y. So, this is the equation. Now, comparing the powers of m of each fundamental quantity. So, first of all we get m, for m x equal to 1, because left hand side dimension of m will be equal to the right hand side dimension of m, so x equals to 1. For L, we get 2x equal to 2. So, from there, again we are getting x equal to 1. And for T, we get minus 3x plus z equals to minus 2. From there, we substitute the value of x and get z equals to 1. And for I, minus 2x plus y equals to 0, so that y equals to 2. So, these are the values of x, y and z. So, you can see what are the values of x, y and z. Now, we get finally h equals to k r I square t. In SI unit, we know k equals to 1. Hence, finally we get h equals to I square RT. And this is our well-known Joule's law of heating. So students, if you found the video helpful for you, then like, subscribe and turn on notifications. So this is the end of the first video.